First, you have to design your part. This piece has a practical purpose for our research lab as a mounting bracket for a camera. It'll be made out of 6061 aluminum. After design, you have to cam it up. This makes toolpaths that a CNC mill can read in order to do all the dirty work for you. You set your tooling and other specs, and off it goes. Then, you actually machine the part. You run the G-code on the machine and slap your piece into the fixturing and let the mill fly. Lastly, because this is space grade, we anodize the part. This makes sure it won't do bad things once in space. So this is our part that we made. You have to take special consideration to not design anything that can't actually be milled. In this case, you can see that there's not any interior angles that are perpendicular to each other, no drastic overhangs or anything like that. You have to consider the type of tooling that you have, and in this case this little groove in the middle is kind of funky, but we ended up making it work. So here we have the part open in Fusion. You can see that we ran our cam, and you can see all the actual toolpaths of what the end mill is going to be doing while it cuts the part. So these blue lines are passes over the top to shave down this blank from this top surface all the way up here down to here. And then the green path is when it's not actually cutting the part, but it's redirecting and moving so that it can go back the other way.
Cutting.
We are cutting the piece out of stock using the jet bandsaw. It is being sprayed with the cooling fluid to stop overheating and damage to the saw.
It's time for facing.
No, not that kind of facing. In the machining sense, facing is a milling technique that has the part fed into the machine to get a smoother, more polished surface. Here, the part is having a small layer removed from the top by the Prototrack SMX, with cooling fluid being applied once again to prevent overheating.
It's time for machining! CNC machining was invented by Martin H. Machining in the early 1800s. During this time period, CNC machining was done using a small machete and a river otter's unwavering grip. Unfortunately, due to the increasing minimum wage for river otters, modern CNC machining is done on machines made specifically for the task, like our Fab Lab's own Haas Mini Mill. After our stock is cut and faced, it is ready to begin being machined. We begin by fixing our stock in the vise, and then use our cam files to cut the stock down to the desired shape. Our first phase used a combination of an end mill, drill bit, and thread tap to cut the perimeter and drill and tap the holes needed. In our second phase, the CNC uses the Orbiana stick, or probe, to tickle the aluminum and know where it's located. Then, we again use an end mill and a ball nose mill to clear out material on one side, leaving us with this. We repeat this process on the other side for a finished part.
Next, a quick vapor blasting, and then we're off to anodizing. Anodizing ensures our part is space ready, corrosion resistant, and looks cooler than regular aluminum. The first step in the anodization process is to thoroughly clean the part and then degrease and dry, ensuring that oils and cloth fibers don't get introduced into the part, as they can affect the finish, both visibly and corrosively. Next, we introduce our part to our anodizing solution.
Our anodizing solution is made up of 2 parts. 3 parts deionized water and 1 part sulfuric acid.
But that's not what this is. This is a gin and tonic to get me through the rest of the video. Cheers. After this, we apply power to our part and to a ground suspended in the solution, keeping the part at 4 amps. We turn the part occasionally to help ensure an even finish, then rinse, and our part is finished.
Overall, our part turned out very well. We did have to do some deburring by hand and clean up some of the threads, but the anodization coat came out even and clean, without many imperfections, and is fairly scratch resistant, indicating that the coat penetrated fairly deep into the part. In doing it again, It definitely would have helped to have a better power supply, as consistent amperage was an issue throughout, and it also would have helped to have a threaded hanging point for anodizing the part to deliver steady power to the part itself, as that also increased their anodizing time. All that being said, the part turned out great, and is well within the spec needed to go to space. Thanks for watching.